All right, so this is our question, and we are going to continue from where we stopped last time. We are looking at the rate of decay, we are looking at the rate of decomposition and cooling. So here comes in a question where we are having a clinical thermometer whose reading is 25 degrees Celsius is placed in the mouth of a patient. The mouth temperature 30 degrees is indicated by the thermometer, rises at a rate proportional to T minus theta. Write down a differential equation for theta. So they want the differential equation. So the differential equation, we are going to say that d theta dt, Roman 1, it will be d theta dt is proportional to T minus theta. T minus theta. But remember the temperature decreases, and when the temperature is decreasing, it means we shall say that the theta dt is equal to negative k, that is a constant, then T minus theta. All right, so this is the differential equation that is required. That is first part, required differential equation is this. So that is the first part. They just wanted to write down a differential equation. So you have to show these two steps. Then Roman 2, they want us to obtain the solution. The solution means we shall integrate, we shall work on it. Okay, so now I will use two methods, or I will show it in two ways. All right, so now to obtain the solution of this differential equation, we shall separate the variables. So from, I will say from d theta dt is equal to negative k t minus theta. Separate the variables. You will have the theta over t minus theta is equal to negative k dt. So we integrate we integrate 1 over t minus theta d theta is going to be equal to the integral of negative k dt. So when you integrate here, you get since it is t minus theta, when you integrate this, you get negative ln. You get negative ln t minus theta. If it was t plus theta, you'd get ln t plus theta. But because of t minus, okay, we bring in the negative ln. From our integration, we can connect this. So this is equal to, when you integrate negative k dt, you get negative kt plus a constant. But I'm saying that a clinical thermometer whose reading is this is placed, meaning before you place it in the mouth at time is equals to 0, all right? The temperature theta is equal to 25. What does it mean? If the temperature is 25, it means that it would be equal to, we are going to have, when time is 0, so negative ln t minus 25, cos theta is 25, is equal to c, because the whole of this is 0, so 0 plus c, which is c. Then if we substitute, we shall have negative ln t minus theta equal to kt plus c, which is minus ln t minus 25, right? So we can bring the ln's together. If you bring it this side, it will be plus, so we shall have ln, we shall have ln t minus 25 over t minus theta is equal to kt. How? When it comes this side, it will be positive. It will be ln positive. So it will be ln t minus 25 minus ln t minus theta. But we say that ln behaves as logarithm. So a point where you have ln t minus 25, then minus ln t minus theta, here we have to divide. So that is what I am trying to do, meaning that if we introduce e both sides, okay, if we introduce e both sides, we shall have, let me move this way. Hope we are there. If you're following me, type yes. If you're following me, type yes, so that I continue the other side. If you're following me up here, type yes. Because if you don't follow me, then here on the proof, we may get problems. So if you're following me, type yes. Okay. I guess let's continue. So I'm going to start from that very step where I have ln t minus 25 over t minus theta is equals to kt. Introduce e, you'll be having t minus 25 over t minus theta is equals to e, or it will be e power what? E power kt. Then now it means that yeah, so or else, yes, from here, now we can, because I am interested in theta. So if I move it up like this, if it is t minus theta over t minus 25, I will have t minus theta is equal to t minus 25 e to the power negative kt. I want you to understand the pure math behind here. Here it is t minus 25 over t minus theta. But if we interchange them, if you move them, if you interchange this up, this one, we shall have negative this side, right? We shall have negative. So reciprocating this brings negative on the left-hand side. So we have this, implying that if we are interested in theta only, theta will be equaling to t minus, right? We shall be having t minus 25, then e to the power negative kt. If you're getting this, let me see. Or if you're having any problem here, you can let me see. Yes, I'm going to use some other approach so that you do not get confused. So this is the solution. Or if you don't want to take that side, or where we had the negative, from that step where we had the negative ln t minus theta is equal to negative kt plus a constant of integration, okay? At this very point, you can bring in e. When you bring e, we shall be having, of course, we shall be having t minus theta. T minus theta is equals to e negative kt plus a constant. So in this case, you'll be having t minus theta is equal to, because this e can be e power negative kt times e power c, whereby e power c I can call it A. All right, so in this case, we shall have A E power negative KT. Then you bring in your condition. When T is 0, theta is 25, implying that by substituting here, we shall have T minus 25 is equals to A. So again, if you substitute, you're going to get T minus theta is equal to A, which is T minus 25 E power negative KT, which is the same as this. So the moment we are not on these steps, then that is where issues come from. But we need theta, so still theta. Check this side, bring this one this way. So it will be T minus 25 e to the power negative KT. That is what we are having. So if you're with me, type yes before we go to the part of the proof. We are going to do very many examples that will have you understand these concepts very well. So the more examples we do, the more you understand. Okay. So let's do part 3. Part 3 is like, given that alpha, beta, and gamma are successive readings of theta at equal intervals of time, show that T is alpha gamma minus beta squared over alpha plus gamma minus 2 beta. So having that question, now our point of focus is this. Let's go with this. So they are saying that given that alpha, beta, and gamma are successive readings at equal intervals of time. So allow me let, for part 3, allow me let T0, T1, and T2 be the successive time intervals. Right? For temperatures alpha, beta, and gamma respectively. So it would imply that from theta is T minus 25 e to the power negative KT. When theta is alpha, so it means that we shall be having alpha is equal to T minus 25 e to a negative KT naught, equation 1. When temperature is beta, anyway, from here we can also have T, you can say T, let me wait to label this equation 1. So if I say T, then I bring this on this side. So it will be T minus alpha is equal to T minus 25 e power negative KT naught. Now let me call this one my equation 1. Then also beta is equal to T minus 25 e power negative KT, implying that T minus beta is equal to T minus 25 e KT1. I call this one my equation 2. Then also for gamma, it will be gamma is equal to t minus 25 e power negative kt2, implying that t minus gamma is equal to t minus gamma will be equal to t minus 25 e power negative kt2. I call this one my equation 3. So I have an equation of t minus alpha, I have an equation of t minus beta, I have an equation of t minus gamma. But the question wants me to find t. So I'm going to let allow me let t1 minus t naught be equal to t2 minus t1, and I let this one to be equal to a constant. I'm going to see how it will come out. Now, if I get equation 2, rather equation 1, I divide it by equation 2. Okay, equation 1 divided by equation 2, equation 1 divided by equation 2, it would mean that I have t minus alpha over t minus beta is equal to t minus 25 will cancel, because in both cases I have t minus 25, t minus 25, so it will cancel here. So I will have a, rather e, then k. Since I'm dividing, I will subtract the powers, so it will be t1 minus t naught. Okay, then I will say that this is equal to e. For this one, I say that it is a constant, so it will be ECK, implying that t minus alpha over t minus beta is equals to ECK. Then further still, I'm going to divide equation 2 and 3. Equation 2 divided by equation 3, so it means that I will have t minus alpha, t minus beta over t minus gamma, and this is going to be equal to E k t2 minus t1, which is also equal to E. This is a constant, so ECK. Now, implying that I have this ECK and I have this E plus CK, so they are equal, meaning that ECK, which is equal to t minus alpha over t minus beta here, is at the same time equal to t minus beta over t minus gamma. But I'm trying to solve for the value of t. So it implies that from here, t minus alpha over t minus beta is equal to t minus beta over t minus gamma. If you do cross multiply, you're going to have t minus alpha times t minus gamma is equal to t minus beta and everything squared, because it is t minus beta times t minus beta. So this is going to be t squared minus t gamma minus t alpha. So gamma t minus alpha t, then plus alpha gamma is equal to, expand this, you'll get t squared minus 2 beta t plus beta squared. But interestingly, I'm looking for the value of t. So this t squared can cancel with this t squared, however, don't cancel like that in an exam. So we are left with, we need the value of t. So I'm having here t and t. So wherever I'm seeing a T, I'm going to bring them together. So I will have negative gamma T, I have negative gamma T minus alpha T, minus alpha T plus 2 beta T is equal to alpha gamma, okay, can say beta squared minus alpha gamma. So you can factorize out a T here, or yeah, can factorize out T or negative T because I want negatives to go. But let me factorize out a T. If you factorize out a T, it will be alpha. No, am I? Yeah, it's supposed to be alpha. Supposed to be gamma minus alpha plus 2 beta is equal to beta squared minus alpha gamma. So the question wants us to show that T is equal to, so here our T will be equaling to beta squared minus alpha gamma over gamma minus alpha plus 2 beta. But according to what I'm given, I'm having alpha gamma minus beta squared. So we can divide through by negative up and down so that we have alpha gamma minus beta squared over, if you divide by negative here, I don't know why this one is keeping positive here. Maybe I think I need to check on the expression of the answer, because if you divide by negative, it would be alpha minus gamma minus 2 beta. That is how the final expression is supposed to be. So maybe we can change on the look, or we can change the expression from the question if at all is okay. I guess I haven't made any mistake anywhere here. So that is how the proof would come out. Here you have to be pure mathematical. You have to put in that extra eye of observation. Yeah, rare.
Excuse me, sir.
Yes, please.
Teacher, here we had a negative, but when you were substituting inside there, we didn't put that negative.
Where negative? Because it is here negative. Negative gamma T. Oh yeah.
When you are substituting. Yeah.
Good. That's a good observation. So it would be, yeah, this is okay. So here we shall have negative gamma. So it happens to be that. Yeah. Very good. So that is how it would come out. Well, that is the first question. I told you that with practice, and not practice of one calculation, no, you have to do a lot of practice. Okay, so let's do some other example very fast so that we save both time and do much. So number 2, the rate of decay, at any instant, the rate of decay at any instant of a radioactive substance is proportional to the amount of the substance, proportional to the amount of substance remaining at that instant, remaining at that instant. If the initial amount of the substance is A, if the initial amount of substance is A, and the amount remaining after time t is x, part A, prove that x is equals to AE minus lambda t, where lambda is a constant. After this question, I want you to check UNEB 2014 number last, paper 1. Prove that x is equals to A, E, power negative lambda t. Then B, if the amount remaining is reduced from a half A to 1/3 A in 8 hours, prove that the initial amount, of the substance, was halved in about 13.7 hours, 12 marks. So that is what we are having as our question. Yeah. The rate of decay. When they say the rate of decay, it means that something was reducing. When something is decaying, then it is reducing in the amount. The amount is reducing. Okay. Now, the rate of decay at any instant of a radioactive substance is proportional to the amount of the substance remaining at that instant. If the initial amount is A and the amount remaining after time t is x, prove that that is true. Now you need to know that for this case, dx dt is proportional to x, because that is the amount remaining at that instant. And you cannot use a different later because you have to separate variables thereafter. So you cannot use a different later when you are going to separate variables. So if the amount remaining after time t is x, then it means that the rate of decay is proportional to the amount. So dx dt is proportional to x. Now, it means that here our dx by dt would be equal to, we introduce a constant and put negative, so it is going to be negative. But if this is negative already, the constant of the decay constant is lambda, so we shall take lambda now. So it will be dx dt is equals to negative lambda x. So don't use your k when they have given you the constant to use. So dx dt is equals to negative lambda x. Okay, so after this, we have to separate the variables, whereby we shall have dx out of x is equals to negative lambda dt. Then here you have to integrate either sides. So when you integrate, we are having 1 over x dx. I prefer this step separated is equal to negative lambda integral of dt. So when you integrate 1 over x, we shall get ln x is equal to, when you integrate dt, you'll get t, so we shall have minus lambda t, then plus a constant of integration. But remember, they told us that if the initial amount is a, so meaning that at time is equals to 0, at time is equals to 0, a, rather x is equals to a, at time is equal to 0, the amount was a, so x is equals to a. Substitute in here and see how you would do. So it means that ln a would be equaling to, it would imply that ln a is equal to, the whole of this is 0, so ln a is c. Now substitute for the value of c here still, so we shall have ln x is equals to minus lambda t plus ln a. All right, so if you bring the ln this side, it means that you will have ln x minus ln a, ln x minus ln a is equals to negative lambda t. Of course, if you're subtracting lns, they will behave as logarithms. So we shall have ln x out of capital A is equal to negative lambda t. Introducing e. Introducing e, we shall have x over a is equals to e power negative lambda t. I guess you remember how we introduce in e. When we introduce e, the ln will go and this one will be a power of e. So implying that here, our x is going to be a. If you take if you cross multiply, it will be equal to ae power negative lambda t as required. If you're with me there, let me see. If you're with me, someone can type yes, if you're with me, but that is how simple it can be arrived at. If you're with me, type yes. Good. Okay, so now part B, they're saying that if the amount remaining, oh yeah, part B is the best. If the amount remaining is reduced from a half A to 1/3 A in 8 hours, prove that the initial amount of the substance was halved in about 13.7. You have to understand that English very well. They are saying that if the remaining amount was reduced from a half A to a 1/3 A, meaning that originally it is a half A, because it is being reduced from a half A to a 1/3 A. So at time is 0, the x is equal to a half A. So that one will help us get the value of maybe a certain constant. Okay, so then in 8 hours, or when t was 8, we get a 1/3 A. So we want to prove time. They want the value of time. So allow me come again and say that from ln x is equals to negative lambda t plus a constant of integration, right? At t is equals to 0, my x was a half of A. So if you substitute, we shall have ln a half ln a half a is equal to C. Bring this value of ln a half a into this equation. So it would imply that ln x is equal to negative lambda t plus ln a half a. Then now for this case, they say that in 8 hours it will have been reduced to a third a. So when t is equals to 8 hours, okay, our value of x will be a third a, right? So that one can help us get the value of lambda. Now it means that we shall have ln a third a is equal to negative 8 lambda, because time is 8, so negative 8 lambda plus ln 1/2. Now we are going to realize that 8 lambda, I can say 8 lambda this side is equal to ln a half a, let me take it slowly, minus ln a third a. So it means that our 8 lambda is equal to, we can consider ln, then a half a over a third a, as will go. So we shall remain with the 3 out of 2 because the other one will move up, because it is a half divided by a third, which is 3 out of 2 after taking the reciprocal. So lambda is 1/8. We shall divide by 8 both sides, then ln 3 out of 2. Now, after getting the value of lambda, bring it here in this equation. We are interested in obtaining the value of t. So it implies that, let me say equation star. So from equation star, it means that ln x is equal to negative lambda, which is 1/8 we shall have negative lambda t, which is negative lambda, which is 1/8 ln 3 over 2, then t, so I can say negative t over 8 plus then plus ln a half a, I guess my substitution is correct. And so in this particular case, I can as well write ln x, because I want to avoid negative here. So if I write positive t over 8, it means that within the ln, I will take the reciprocal 2 over 3. You need to understand this math. Then plus ln a half a. When you take the reciprocal, rather when you change the sign, then you have to take the reciprocal of the variables of ln. Okay, so we are having this. Now, they told us that we proved that the initial amount was halved. So when the initial amount was halved, that is when x is halved, it means that it was already a half. Yes, x was equal to a half originally. It was a half a. So when it is halved, it goes to a quarter a. So when x is halved, remember x is a half a originally. So when you have it, it will be ln a quarter a is equal to t of 8 ln 2 out of 3 plus ln a half a. So now looking at this, looking at this, we can bring this one this side. Can bring this one this side so that we have ln a quarter a minus ln a half a. That one will be ln a quarter plus ln a quarter minus ln a half. So it will be ln a quarter a minus ln a half a, right, is equal to t over 8 ln 2 over 3. So this is the same as ln a quarter divided by a half. So this is ln a quarter times 2 over 1. So I'm having ln 2 over 4. Yeah, I'm having ln 2 over 4. So here we shall have ln 2 over 4 after applying the logarithms is equal to t over 8 ln 2 over 3. But remember, I'm looking for the value of t. So how do I get the value of t? The value of t is equal to, you will cross multiply, 8 will come this side. So it will be 8 ln 2 out of 4 divided by ln 2 out of 3. Someone to put this one on the calculator for us. So what is our value of t? Let's see if the answer is 13.7. Someone to put it on the calculator very fast and you tell us. It is after these questions that we shall also attack those questions in the QB to make general revision of this area. What do you get as t? I'm getting 13.676, which makes t go to what they want, 13.7 hours. And that is what is required. So you have to pray very well with your calculation. The moment you make a mistake somewhere in the middle, you can lose it. But good thing, the way of answering these questions is uniform. Okay, they are answered in the same way. So you can't be like, I've made a mistake. By practicing, you can avoid mistakes. If you don't practice, you will be making mistakes. So the best way to avoid mistakes is to practice. If I'm clear there, type yes, because I want to introduce the rate of formation, growth, and spread. I do one example, I leave you with one more example to do. If you're with me, type yes. Okay. So we leave that part. We leave that part to rate of formation now. So all the rates of decay, decomposition, cooling, you do in the same way. Okay, so now let's do some example on rate of growth. Formation and spread. Growth, formation, and the spread. So for this case, let's have an example done also. I will do you one, you'll do many of them. In this example, I have the rate of growth of a substance is proportional to the original sorry, let's write this. The rate of growth of population in Uganda is proportional to the number of people living at that time. The rate of growth of population in Uganda is proportional to the number of people living at that time. In 1980, Uganda's population was 18 million, and in 1990 it was 22 million estimate. Roman 1, the number of people in Uganda in 2005. Also estimate how long it will take the population, to reach 36 million. Okay, now let's interpret this question. First of all, if we say rate of growth, formation, or spread, I gave you a condition whereby a rumor is spreading in a certain village, provided it leaves the mouth of one person, the bearer, and it goes to another person. It means that that rumor has started spreading. You won't stop it. Even after years, you'll find the same thing being talked about. If provided the cow has been born, it will keep in a, and for as long as it keeps in existence, it means that more other cows are going to be produced. That is growth, spread, formation. So in this case, you cannot expect a country to have a constant population unless otherwise. Even though there are wars, but still people keep producing. So what does it mean? When we say rate of growth, formation, or spread, the rate at which it occurs is positive. So when they say the rate of growth of population in Uganda is proportional to the number of people living at that time, you can engage in a common example, or you can engage in a real life example. In the past, not even far away from today, in the early 2000s, the people who would graduate at the university, the fact that it was by that time Makerere and Mbarara, because in early 2000s, Mbarara was there. So the people that would graduate would be attributed from Makerere and Mbarara. But previously, before Mbarara, it was only Makerere. Now imagine a scenario whereby at the first graduation had 4 people. And now you imagine the situation of graduation this time. You find even the people who are graduating with a doctorate are above 4 in a certain department. So implying that the rate at which the education system of Uganda became substantial is high, it is growing. So you can't expect things to still be done in the same way like the past. In the past, someone who would be having a smartphone would be the billionaire of the clan. But right now, P1 child is on Zoom using a smartphone. People are having iPhones. Imagine when these smartphones have not come, you would rarely even see someone with this phone of buttons. But right now, when someone is holding it, sometimes it looks a bit funny. To you who have them, it looks a bit funny, implying that the rate at which modernity is taking us is too exponential. So if you're interpreting this question, they're saying that the growth of population in Uganda is proportional to the number of people living at that time. In 1980, the population was 18 million. In 1990, it was 22 million. Can you estimate the number of people that will be in Uganda in 2005? This is a mathematical model from the branch of biomathematics, whereby even one can specialize in doing this research in the hospitals. One can perform a Poisson experiment. If 15 ladies in this month have produced boys, and the other month maybe 60 women have produced boys, how many boys will be produced by maybe 100 women? Okay, one can estimate. So here we are looking at what population will it be by 2005 if it is growing like this. So you have to first generate a model that will give you a differential equation. Then from that differential equation, you obtain a solution, and then you start substituting for what they want. So let's see. They are saying that the rate of growth of population. So I'm going to use P to represent my population. Let P stand for the population. And if that is the case, they're saying that the rate of growth of population, meaning dP dt, is proportional to the number of people living at that time. So it is proportional to the population at that time, implying that dp dt is equal to, now here don't put negative, you put negative if there is a decrease in quantity, but the population is not increasing, or rather is not decreasing, so we shall have a positive. I can use lambda p, where lambda is my constant. If you use a different constant, which is not given in the question, apart from k, you have to define that constant. So you can say lambda is a constant. Now from here, you can separate variables. So on separating the variables, you have dp over p is equals to lambda dt, right? And there you can integrate either sides. When you integrate dp over p, you get ln p is equal to lambda t plus a constant. So implying that our p would be equaling to e. I have introduced e both sides. Ln will go. This side will be lambda t plus a constant, which when you worked on, this is the same as p is equals to e lambda t times e to the power c. But e to the power c, a is equals to e to the power c. Allow me call my e to the power c a. So it means that my p would be equal to a e power lambda t, right? That is my differential equation, and I've solved it. This is the solution to my differential equation. The differential equation is this. This is its solution. But now, to answer the questions given to me, I have to go back and interpret all that information. They are saying that in 1990, that is initially where they have given us. So I would say in 1990, that is when t was 0, because that is where I'm starting from. What is the population? The population was 18 million. So P is 18M. Allow me use 18M. Maybe I can bring the M in millions later. So I'm taking 18M. So from here, it means that t is equals to 0, p is 18m. So I will have 18m. Don't say just 18, because the million may get lost. So 18m is equals to a, the whole of this is e to the power 0, which is 1, so it is equals to a. So substitute for a, it means that we shall have p is equals to 18 millions e to the power lambda t. Now, after getting that, in 1990, this was in 1980. This was in 1980. So now we are going in 1990. In 1990, t would be 10 years. T will be 10. Now, they have not told you that t is 10, but logically, from 1980 to 1990, the time interval is 10 years. So if t is 10, the population now will have risen to 22 million, according to what they told me. So if that is the case, it means that substitute, it will be 22m is equal to 18m e power 10 lambda. But million and m and m will cancel. So if m and m cancels, okay, I will have I will have 22 over 18 is equals to e 10 lambda. Now, to get lambda, of course, you have to introduce ln again. So it means that ln by 2, it is 11 over 9. So ln 11 over 9 But this side, when you introduce ln, now it will be 10 lambda. It's no longer a power. Meaning if you introduce e, it goes back to the power. Okay, so ln 11/9 is 10 out of lambda. So implying that my lambda will be equaling to, I divide by 10, so it will be 1/10 ln 11 out of 9. So after getting lambda, I will bring it here again. So let me call this one equation star. So substitute lambda into equation star, implying that my P would be equaling to 18m, should be equaling to 18m, E, then T times lambda, which will be, if it is T times lambda, it is going to be T over 10. I'm just substituting for that, T over 10, then ln 11 out of 9. Now, the first question wants me to find the number of people in Uganda in 2005. So we shall count from 1990 to 2005. What is the time? 1990 to 2005. What time is that, members? So in 2005, actually from the original in 2005, that is from 1980 to 2005, time will be 25 years. So in 2005, that is when T is 25 from the original. Okay, T is 25. So I will substitute for T as 25. I get the population. So the population would be 18m E 25/10 ln 11/9. Now here the calculator, you be careful so that the calculator doesn't disappoint you. On the calculator, there is no m. So for you, first evaluate E power 20. You can reduce this. Actually, if you want to put it on a calculator, I told you that the calculator has two E's. It has a calculator which is italic, and has a calculator, it has an A which is written very well. If you use the written very well E, don't put a power, just put E, then you say you can put 25/10 ln 11/9. Then the answer you get, multiply 18, then maintain m. Right? So in 2005, the population of mine will be 29.727 million. But the question is, we don't have people who are halves. You can't say that this person is a half, this person is a quarter, this is a full person. So when you're evaluating the population, you have to present the people. But maybe because you are going to multiply million, the zeros, okay, the zeros will take away this goal. So the population, can conclude and say the population in 2005 will be 29.727 million. Now, if you're with me, type yes for that. If you're with me, type yes. If you're with me, type yes. If you're with me, type yes. That is the population in 2005. So differential equations can help you predict what is going to happen in some time if you use the statistics very, very well. So the last part of that question, I want us to be very fast. I leave you with one question and we'll go. The last part, they want us to estimate the time or how long it will take for the population to reach 36 million. So where P is 36 millions, we want to get the value of T. This should be our reference equation. Actually, what should be our reference equation? Where we need T and P should be our reference equation when all constants are being gotten. So from P is equals to 18m E T over 10 ln 11 over 9. Substitute. Population is 36 millions is equal to 18 millions. E, we need time, then ln 11 out of 9. So M will go here. This side we shall have a 2. We shall have 2. So we shall say 2 is equals to T would be equaling to E, then T over 10 ln 11 over 9. So to remove E, we introduce ln both sides. So we shall have ln 2 is equals to ln 2 is equals to T over 10 ln 11 over 9. You remove the E, but not this ln. Okay. Then now you can cross multiply. When you cross multiply, you'll have 10 ln 2 is equals to that. So 10 ln 2 is equals to T ln 11 over 9. So you can get your T as 10 ln 2 over ln 11 over 9. So T will be equaling to how long will it take? So T will be equaling to 34.54 years. So you conclude and tell me that it will take 34.54 years for the population to reach 36 million. That is it. And I won't continue from there. That is what I can offer for today. But I have to leave you with a question which I need you to do so that we start from there next time. So I'm leaving this question to everyone. So that you do what you can and see if you can get the answers. Okay. Activity is about bush burning. So the rate at which bushfire spreads is proportional to an burnt area of the bush. A burnt area of the bush. Initially, when observation was made, comma, 1/5 of the bush had burnt. Had been burnt. 2 hours later, a third of the bush area had been burnt. Find the fraction find the fraction of the bush area that will remain unburnt after 5 hours. Okay, the rate at which the bush fire spreads is proportional to unburnt area of the bush. Initially, when the observation was being made, 1/5 of the bush had burnt. 2 hours later, a third had been burnt. Find the fraction of the bush area that will remain unburnt after 5 hours. It seems tricky. The 2B has the simplest questions. You can also practice them, but do this. Okay, do this and see if you'll come up with a half. Should come up with a half without forging it. Should come up with a half as the fraction. So that one we have moved, and I really think we shall do great as time goes on. I wish you the best for today. That can be enough for us. Keep practicing. The 2B has very many questions which are easier for you, and the questions don't come from heaven. They are real life questions. So go do your best. God bless you.